Hi, this lesson we will look at statistic 2, Poisson distribution partial questions. What I would like to discuss here is to show you what syllabus wants candidates to know and how does the exam questions look like. Now, candidates should be able to, from the syllabus, use formula to calculate probabilities for the distributions. So when it indicates PO, means Poisson distribution and the parameter lambda. So I will write down the formula here. All right, this formula is given in the formula booklet MF19. And then second, understand the relevance of the Poisson distribution to the distributions of random events and use the Poisson distributions as a model. So that means we need to identify the exam questions when we are using these Poisson distributions. So in other words, we need to know the conditions. And there are 4 important conditions that a Poisson distributions can be used. So the random variables has to occur, that means occur randomly, independently, singly, and at a constant mean rate. All right, when a particular exam questions, which means the random variables given occur randomly, independently, singly, and at a constant mean rate, then these questions we will use the Poisson distributions to calculate the probabilities. So that's where I'm going to show you an exam questions. And then we are going to go through these 2 points that what syllabus wants students to know. Now, this is a question from May-June 2008, question 6. People arrived randomly and independently at the elevator in a block of flats at an average rate of 4 people every 5 minutes. So what do we have here? First thing, we try to see that X, a random variable, is talking about number of people arrived at the elevator, right, in a block. So what do we see about this random variable here? As the question emphasized, it occurs randomly and independently, right? Random, independent. And then another important point, at an average rate. So that is what it means by constant mean rate. So when a question emphasizes this point, then we know it is looking at the Poisson distributions. Another thing I'm using to determine if we are looking at a Poisson distributions is that if we look at the random variables here, the number of people arrive at the elevator, right? In the 5-minute interval, you can see that the number of people in that 5 minutes, right? Whether it can be no people at all until there are many people at the elevator, right? So whenever it has the characteristic that from none to many, then the random variables should be a Poisson distribution. So for this case, information given to us is 4 people in a 5-minute interval. All right, now we are going to find the probability. All right, so we have to be able to identify a question. So according to this point in the syllabus, knowing that this important point, random, independent, and the constant mean rate, to identify that we are using a Poisson distribution here. Then second, we are going to calculate the probability, right? And using the formula, which is given in the formula booklet. So I need to scroll down, and then let's calculate part 1. Find the probability that exactly 2 people arrive in a 1-minute period. And the exam question would always like to ask the questions where they change the interval. Now, in the information given, we have 5 minutes. The constant mean rate is 4 people. But now the interval given is 1 minute. So we must change the mean rate according to this interval given. So hence, proportionally, 4 divided by 5 and then multiplied with 1. And this is where we are getting the mean, constant mean rate, and which is 0.8 for 1 minute interval. So the Poisson distributions that we are using here, where the parameter, which is the constant mean rate, is going to be 0.8. Okay, then now we are going to calculate the probability. So when the probability is asking exactly 2 people arrive in the 1 minute interval, so equals to 2 in 1 minute. So according to the formula, which is e to power of negative of the mean, the lambda here, 0.8, then times with this to power of the r. The r in this case is the 2, right? Divided by 2 factorial. So which is same as the probability of 2. Okay, then we can press calculator and calculate out the value. Equals to 0.144 round off to 3 SF. Okay, so that is what we get for part 1. Now, move on to part 2. Find the probability that nobody arrives in a 15-second period. So now it changed from minute to second. So which means 5 minutes and they are expecting 4 people, right? So 5 minutes means 300 second, and then 4 people. So now we're expecting a 15-second interval. What is the corresponding mean rate? So proportionally 4 over 300 times 15. And calculate from here, we are going to get 0.2. So for part 2, the Poisson distributions parameter is going to be 0.2 in 15 seconds. Okay, then finding the probability that nobody arrives, which means x equals to 0 or p0, right? Either way will be fine. And we sub into the formula e to power of negative 0.2, 0.2 to power of 0 over 0 factorial. So now we need to see that anything to power 0 is going to be 1. 0 factorial is also going to be 1. So you press calculator and we are getting the probability to be 0.819. Round off to 3 SF. All right. So now we move on to part 3. So I need to scroll it down. Okay. So answering part 3, the probability that at least one person arrives in the next t minutes is 0.9. Find the value of t. So this case, the probability is given 0.9. So what do we do? Again, 5 minutes. The mean rate is 4 people. So now we have a t minute, which means the constant mean rate is going to be 4/5 times t. That means the Poisson distribution now, we are looking at the constant mean rate to be 4/5 can be written as 0.8 t, right? In t minutes. See, everything is the same. Now, finding probability that at least one person arrives, which means x is greater and equals to 1. And this probability is equal to 0.9. Okay, so for these questions, probability is given. We got to calculate and get back the t minutes. So another characteristic of Poisson distribution is it doesn't go to the right side. Wait, what do I mean? X greater and equals to 1. It means like it can be 2 people arriving in the t minutes, or 3 or 4 or 5, right? So to the right side is never ending. So in order for you to calculate probability that working towards the right, you have to take 1 minus probability that x less than 1. Right? As we know, total the probability must equals to 1. And for this case, x less than 1, the probability can only be x equals to 0. All right. Okay. But then you are not supposed to take whatever we calculated in part 2, right? Part 2, which is finding probability x equals to 0, but it is in 15 seconds and the mean is 0.2. So now it's in t minutes. So the interval is different. The mean rate is also different. So which means we still have to put this in to the into the formula and calculate again. 0.8 t. Right? So we calculate from here. So same thing, anything to power 0 is going to be 1. 0 factorial is also going to be 1. Then you're left with this. And it's a negative. And you bring the 1 to the other side, 0.9 minus 1 is a negative 0.1. Since both sides are negative, so we get rid of it. And at the same time, I multiply ln both sides. Right, we have already get rid of the negative 1 and we put ln both sides. And the reason is to bring down the negative 0.8 t. And we know that ln e is going to be 1. And that is where we are going to calculate out the value of t. All right. And value of the t using calculator, and it's going to be 2.88 round off to 3SF. So we have found for this particular questions, probability 0.9, the interval, the t minutes is going to be 2.88 minutes. All right. All right. So these questions is in exam, and then it's asking you about Poisson distributions, and depending on the syllabus given, you have to be able to use the formula to calculate the probability. And you have to be able to see that the questions with this information given, then you know you're going to use a Poisson distributions and to find out the answer, right? Answering the questions. So for details of Poisson distributions, where are these conditions? I have explained in another video. You can search the Poisson distributions, and then you should be able to get the video. So that's it for this lesson, and do subscribe to the channel and like this video. I see you in the next one. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.